Okay, guys, so today what I want to do is I want to talk about uh, some problems, and we're going to have fun with some of these problems together. And some of these problems go back to previous sections, and of course, then I'm going to tackle some problems from 7.5. If you have started doing 7.5, you probably feel like, oh, it seems like it's the same things we've been doing, but now it doesn't give us any direction, and we don't know which section it comes from, so we're not clear what method we're supposed to use. And that's the purpose of 7.5. 7.5 is not supposed to be some new topic. It's supposed to be, okay, I give you all these tools. The author feels that you're given this many tools from 7.1 through 7.4, and even 5.5 with substitution. Now put them all together and try to answer each of these, solve each of these. When you next quarter to go to 1C, you're going to have a similar situation when you do what we call testing a series for convergence. So there are a sequence of tests you're going to learn. And then there's a section that just says, okay, now these are the series. You decide how to decide convergence of those based on the tests you have learned and which test to use. So it's kind of like a common thing in mathematics and math teaching that you learn strategies, and then at some point then they don't tell you what strategy to use. They just say use whatever strategy works, and that's the purpose of 7.5. So we get to that too, but there was a couple of questions from before that. I had people come to my office. I was asking, so I thought maybe I tackle those for you, and then we're going to see how we can do some problems from 7.5 too. So be patient with yourself when you do 7.5, because it's not, as I said, it's not like integration by parts, just you know what to do. It's like you have to try a couple of things, and maybe the first few things you try doesn't work. It's okay, then try something else. So or come ask me, or post a question on a discussion, see if anybody can help you with that, or I can help you with that or what. So let's start with this problem. This is problem number 29 on 7.1, and the student asked me a question that was similar to this, but I'm not quite sure which problem it was, but this is exactly the same one, but with bounds and different numbers. That's the same exact problem. So I hope this answers your classmate's question as well. So you get something like this, and it is intimidating because you're like, I have three things to decide. And this is from the section that we did integration by parts, right? 7.1. But I could just cover this and say, solve this, and you should be able to do that. And it's intimidating, as I said, because there are three functions, and you're like, well, which one's going to be u, which one's going to be my dv and such. Well, is there a better way to do this? And then you remember, well, there is a trig identity that says sine of 2x is 2 sine x cosine x, which means sine x cosine x alone would be 1/2 sine 2x. So I get 1/2 0 to pi x sine 2x dx. I have students asking me, they're like, well, do I need to remember all these trig identities? I don't remember a lot of these things. It's been a long time, and that's totally, these are all good, valid reasons. But the way I think about it, you don't have to remember every trig identity, but as you do homework problems and trig identities pop up, remember those and have those in your toolbox for the next set of problems. Normally, you don't get much different from those trig identities that you see in the homework regularly. Now I can do integration by parts. Here I let u be x, dv be sine 2x dx, du is dx, v is negative 1/2 cosine 2x, integrating that. Okay, so this is going to be negative 1/2 x cosine 2x, which I integrate, and there's, by the way, there's a 1/2 sitting out there from 0 to pi. Minus is plus 1/2 0 to pi integral cosine 2x dx. Let me actually pull out all the 1/2, so I get negative 1/8 pi cosine 2 pi minus 0 cosine 0. So that's this first part. Minus, and then antiderivative of this part is going to be 1/2 sine 2x from 0 to pi. Just to clarify, when I pulled out negative 1/8, that negative come out, this became a negative. Sorry, 1/4. That became a negative. So you have a positive and a negative. The negative came out here with the 1, 2, 3, 1, 4. Then I plugged in pi and 0 in there. Then that 1/2 is gone, but there's a minus there because I pulled out a negative 1/2, right? Then I have an integral antiderivative cosine 2x is positive 1/2 sine 2x. So that's this. That negative is because of the negative that was factored out. Okay. So this one is okay. So it's going to be negative 1/4. Cosine of 2 pi is 1 times pi is pi minus 0 minus sine of 2 pi is 0 plus sine of 0 is 0. So all I'm left with is 1/4. Okay, so that's how you do this. Now, so that's one of the problems that came up, and I thought it would be nice one to try together and show you how to work with this one. And then when from 7-2 to trig sub, I had a couple of nice problems. No, sorry, from trigonometric integration, not trig sub. From trig integration, there are a cosecant cube came up. So one of your classmates asked from number 40, which is a very nice question. Because we know secant, right? Now cosecant cube. Maybe I give you the strategy, the general strategy for this one, and then you'll see how to handle this. So cosecant cube, and 40 actually is a definite integral. There are bounds for it. But what I'm going to do is I'm going to first calculate the antiderivative, then I'm going to plug in the bounds, okay? So it depends on what you want to do. I've seen students who just go through it by just plugging the bounds as they go, and they do a fine job. It's perfect, everything works out nicely, but personally, I think it's better to just go on the side and do cosecant cube x dx, do that separately, and then go ahead and in here, plug it in the bounds and then do the antiderivative, see what happens. Totally up to you, do what works for you best. So I'm going to rewrite this as cosecant squared x dx. This is my dv, this is my u. So u is cosecant, dv is cosecant squared x dx, v is negative cotangent x, du is negative cosecant x cotangent x dx. So this is going to be negative cosecant x cotangent x minus integral of cosecant x cotangent squared x dx. I'm going to write cotangent square as cosecant x squared minus 1. That's for cotangent. And then I'm going to multiply it out. Yeah, very good. So it's a cosecant. If I ever write cosine here, please correct it. It's supposed to all is cosecants. This is obviously what we're looking for, right? And I don't know why we wrote this, but yeah, I don't know why we wrote this. So this is going to go to the other side and combine with the original cosecant cube. So you have twice of the integral of cosecant cube x dx is negative cosecant x cotangent x plus, and let's just do cosecant x multiply top and bottom by cosecant x plus cotangent x. Yeah, that's it. I write more cosines than cosecants, obviously. That's a trick that I showed you guys for secant, and it works the same for cosecant. So let me clean up this part, and then we're going to solve for cosecant. And then this one, you get cosecant squared x plus cosecant x cotangent x over cosecant x plus cotangent x dx. Obviously, we get u be this, and above is negative du. So I get negative cosecant x cotangent x minus natural log of cosecant x plus cotangent x. That's twice of the cosecant. So cosecant cube would be half of this. We'll put the negative out there, why not? And you can just plug this in here and now solve this. So you can use a calculator or whatever to calculate that. But again, as I said, it's just kind of like secant cube, but now you're doing working with cosecant. Just there's negatives, more negatives than that pops up. So pretty cool, I think. Oh, 48 is also a nice one. Let's do 48 together. I don't know if I did 48 for you in the previous video, but it's one of my favorites because it's I see it in upper classes sometimes, shows up in a homework problem or as part of a problem. By the way, secant shows up a lot. Secant cube, cosecant shows up, and it's always a nice, pleasant flavor to the problem because the mechanical steps of it are pretty nice. So this is problem number 48 in the 7.2 section. So I have 1 over cosine x minus 1 dx. It's written slightly differently there, but that's what it is. And then what I'm going to do is, and the trick for this is this: you have 1 over cosine x minus 1, multiply top and bottom by cosine x plus 1. So multiply by what we call quote unquote the conjugate of this. So I get cosine x plus 1 over cosine square x minus 1. Now, obviously, if I change the denominator, I get negative cosine x plus 1 over sine squared x dx. Because 1 minus cosine squared, you add sine squared. Then I guess I can break it into cosine x over sine squared x and 1 over sine squared x. Cosine x over sine squared, I will let u be sine x. Du is cosine x dx. So I get negative 1 over u squared du. This one is just 1 over sine is cosecant, so it's cosecant squared x. So this is negative, and after that, 1 over u is negative 1 over u, and u was sine x. After that, the cosecant is negative cotangent, so negative cotangent x plus c. So good negatives all cancel out. 1 over sine, which I think now we know is cosecant plus cotangent. Let's see. You could have also write cosine over sine as cotangent times secant. It could have cosecant, and then antiderivative that, of course, would be cosecant. So you could have done it that way too. Just whatever comes to mind, whatever you do that works for you, that's perfect. Okay. Now, in the 7.3 section, I had one of your classmates ask me about question number 25. A very nice question. Very nice question. Make sure it is 25. I'm probably going to new sheet for that one. Actually, we can try. Let's see if we can try to write it. So 7.3 number 25. It's integral of x squared square root of 3 plus 2x minus x squared dx. Okay. So the trick again, it's a trig substitution. Now, I don't know if you didn't know this was a trig substitution topic, would you think about it? I like to think you would, because you have a radical that you want to get rid of. You could do a u sub under the radical, but then you need that du part, which is 2 minus x. 2 minus 2x, I don't know. Yeah, you don't have that outside. So I don't think there's really much other options. I think our only option really is to consider trig sum. So, and the trig sum for this is actually a little bit tricky, because you have to actually do a complete square, complete the square in the bottom. So 3 plus 2x minus x squared, I'm going to write it as negative x squared minus 2x plus 3. Then I'm going to add and subtract 1 to this. So half of 1 negative 2 is 1. Squared is 1. So add and subtract 1. I get x minus 1 squared plus 1 plus 3, which is plus 4. So it's going to be integral of x squared square root of 4 minus x minus 1 squared. So this is really the biggest part of the problem, to make sure that you do this to see the trig substitution. And then you actually combine these two together to get your sub. So you get x minus 1 is 2 sine theta. Yeah. Neat, huh? And then x squared, x is 2 sine theta plus 1. So x squared becomes 2 sine theta plus 1 quantity squared. And underneath you have 4 minus 4 sine squared theta. And dx is 2 cosine theta d theta. If I just take the derivative of this. Okay. All right. So magic, this part is going to become 4 cosine squared, because we got 4, 1 minus sine squared, which is 4 squared. Let's just write it out. I'm going to need to go to the next page. Yeah, very good. Okay. Then we have 2 sine theta plus 1 squared, 2 cosine theta times 2 cosine. Yeah, we see something's happening here, right? Yeah, it's gonna be fun. So I got a 2 here, 4 here. No, sorry. No, let's not go. Just 2 and 2 is 4 is here. I have 4 sine square theta plus 4 sine theta. Yeah, let's see that will work. Plus 1 times cosine squared theta. I think we're going to drive this one home, just so you guys can see how to finish this problem, because there are a lot of some details we have to worry about. So multiply it out. And split them. I guess the best way to say that is split them up. And then 4 sine squared cosine squared is actually 2 sine cosine squared, which is sine 2 theta quantity square. This one now is 16. And I'm going to let cosine be u. Sine is negative u, so it's going to be a negative negative u squared du. Because derivative of cosine is sine. And I think for the last one, I'm just going to have to do the double angle identity. 1 minus plus cosine of 2 theta over 2. I see no other way of going there. And I'm going to do the same thing for the very first one now. 1 minus cosine of 4 theta over 2. That's a double angle identity. Minus 16 times 1/3 u cubed. There's a plus c. There's going to be always a plus c. Plus 2, 1 plus cosine of 2 theta d theta. There's a plus c. I can say plus c1 and plus c2 and then change it, but I think we can just get away with just altering c as we go. So I get 2, 1 minus cosine of 4 theta d theta, minus 16 third. Remember, u was cosine cube theta, plus 2 theta, plus 1/2 sine 2 theta. There's another c coming out of this, so that c now gets to be a different c, but not a problem. And yeah, then let's do this one. I get 2 theta minus 1/4 sine 4 theta, plus a c that goes at the end, plus 16 third cosine 3 theta, cosine cube theta, plus 2 theta plus sine 2 theta, plus c. Now this is it. Yeah. And then now just clean it up. 2 theta and 2 theta is 4 theta. Yeah. Minus 1/2 sine 4 theta, plus 16 third cosine cube theta, plus sine 2 theta, plus c. Just to be clear, let's just put the equal signs on all equal statements. Yeah, it was a journey, right? It was a journey. But it's doable. Just patience, just go through it step by step, line by line, equation by equation, expression by expression, see what happens. It's yeah, there's possibilities of making errors all these places, but at least you want the strategy and you want the general strategy there for yourself. Basically that one, the 23, 24, 25, 26, 27, 28, 20, yeah, 28. Those are all completing the square process of the completed square. Yeah, if you couldn't do some of them, just shoot me an email or put it on Canvas and I'll do that for you, no problem. Okay. And then in 7.4, yeah, that was good. 7.4 was good. I got a couple questions here. Let me gather thoughts. There was, yeah, number 16 came up, I think. What's a 16? No, 16 is not bad anyway. Let's do 16. Because it involves long division. I think I did long division notes for the lecture before, but let's do one more. Let's do 16. No problem. Yeah. The thing with these is don't lose patience, but just do the best you can, go as far as you can, and see what happens. But this is 7.4, number 16. And it is integral from 1 to 2. Yeah, there's a definite integral. I hope by now you guys know when I said definite integral, I mean I have finite bounds for my integral. I get x cubed plus 4x squared plus x minus 1 over x cubed plus x squared dx. So again, we do long division here. x cube into x squared cube how many times? One time. Then subtract. And that's it. So you get 1 plus 3x squared plus x minus 1 over x cubed, which is x squared times x plus 1 dx. And then this one, you have to do PFT on it. So you get 3x squared plus x minus 1 over x squared x plus 1 is something over x, another thing over x squared, and another thing over x plus 1. And they're all going to be just numbers on the top. So we're going to calculate the a, b, and c by first taking common denominator. Remember, a used to have an x. Now you want it to have an x squared, x plus 1. So it's missing one more x and an x plus 1. B already had an x squared, is missing an x plus 1. And c had an x plus 1, is missing an x squared. That's equal to 3x squared plus x minus 1. Now I'm going to choose my numbers carefully. I'm going to pick x being 0. Negative 1 is equal to b. X being negative 1. 3 minus 2 is 1 is equal to c. And then I'm out of numbers, right? I can try anything else. Let's just try 1. 3 plus 1 is 4 minus 1 is 3. There's going to be 2a. 2b, but b is negative 1, so negative 2. 1c, but c is 1. So 2a is equal to 4. A is equal to 2. So 2, 1, negative 1. And then antiderivative of 1, of course, is x plus 2 ln of x plus 1 over x plus ln of 1 over x plus 1. 1 to 2. 2 plus 2 ln of 2 plus 1 half plus ln of 3 minus 1 minus 2 ln of 1, which is 0. Minus 1 minus ln of 2. So I get 2, this is 0, actually negative 1 and 2 cancel out. So I get 2 ln of 2 plus 1 half plus ln of 3 minus ln of 2. Oh. So I get ln of 2 plus ln of 3 plus 1 half. If you desire, you can write as ln of 2 times 3, which is 6. And that's your answer. Okay. I don't see anything else there that was asked or was of concern. But if there is something else, let me know. We can make another video on this. No problem. See what I did here, though? I picked 0 and negative 1 because that would make this 2 or this 2 0. Right? Sorry, negative 1 would make these 2 0, 0 make these 2 0. But nothing made these 2 0 and not this part 0. So I just picked another number. I already know my B and C. So picking another number helps me find A. And why did I choose 1? Because 1 is easy to plug in. If 0 wasn't already used, I would definitely use 0. 0 would be easy to plug into. Okay. Number 4. Now this is in 7.5. Now we're in 7.5. Let's do number 4 in 7.5. One of the favorites is sine cube x, because we didn't do much of a division. You remember, we don't do really much of a division. We do multiplication. We don't do much of a division of sine and cosine. So I'm going to peel one of the signs off. I'm going to write it as sine squared x times sine x. I have a plan for this sine x. That's why I filled it up. Cosine x dx. Then I'm going to let u be cosine. My plan is to let u be cosine, right? So if I'm letting u be cosine and du would be sine d, negative sine dx, then sine squared has to be converted to cosine. So, and that's the strategy. So as I said, let u be cosine, du is negative sine dx. So it is 1 minus u squared over u minus du. And when you get to this, yeah, split it, of course. 1 over u plus u du. Sorry, minus. I pushed the negative through, even though I didn't. So minus u. So it's negative ln of u plus 1/2 u squared plus c. Obviously, u is cosine, negative ln of cosine. Very nice. 1/2 cosine squared plus c. So that's one of the. It just seems like, well, what do we do here now? Where do we go with this? So that's what you do. Well, number 8 is t sine t cosine t. Is similar to the one I did from 7.1, which is x sine x cosine x. Similar idea. This is number 10. This is number 10. Number 10 is cosine of 1 over x cubed. Very, very unusual representation, but it's not that bad because I feel like, well, if anything, I'm going to probably have to let 1 over x be my u. So u is 1 over x. Du would be negative 1 over x squared dx. So that's going to be my plan, right? So let's see. So it's going to be cosine. Still, let me not introduce u yet. Let me see if I can make this happen. So I have cosine of 1 over x. I'm going to use the x cubed. I'm going to write it as x squared times x. 1 over x squared, 1 over x squared dx. 1 over x squared dx is your du with a minus. Cosine of 1 over x is cosine of u. And then I'm going to have another 1 over x. Hey, just call that u2, right? So it's negative cosine of u for this part. And negative for 1 over x squared dx is du. And then 1 over x that you have in the bottom, 1 over x that you have in the bottom makes you another u. Yeah. So again, you split the x squared to x, x cubed to x squared and x. And then you do u sub for 1 over x. Yeah. And then, of course, you know where we're going with this. This is a by parts one. Because I already used u for this. So I usually tell students is like, if you remember, when you're doing u sub, don't actually do a u. Use a t or use an s or use a v or something. Because if you end up having to use an integration by parts as well, and if you are very comfortable with u-v combination for integration by parts, if you already used up your u, then that letter cannot be used again for integration by parts. Maybe it's best to use a different letter to substitute. Substitutes are easy, but integration by parts, a lot of people are fixed on the letters. Anyways, I'm sure you figure that out now. And dv is cosine u du. V will be sine u. dw is du. So it's negative u sine u because of the negative. And then there's a minus becomes plus, integral of sine u du. So negative u sine u minus cosine u plus c. And of course, now u is 1 over x. And that's how you do the integration by parts of that. Oh, by the way, did you guys see number 20? This is like a trick question. You guys probably would. Let's fit it here. You guys probably call it a trick question because it's integral of e squared dx, right? Dx. And people will make mistakes. They would say, oh, it's going to be e to the 1/2 e to the 2 or whatever, because you think about it. But it's a constant. E to the x, e to the 2 is just a number. So antiderivative is just going to be that number times x. So it's a, I think Stuart is playing games with us here. Yeah. Anyways, so I hope some of these problems help you. I like to do even more problems for you guys as you ask me, and I see people come to my office are going to ask me questions about these. But I don't, as I said, I don't know which specific ones would help you best, except the ones that I do that I know I've had students having issues with them in the past. So I like doing those for you. If you get stuck on something, just just post a Canvas message on it, and or a Canvas discussion, and I'll go ahead and do that one for you in my next video. I'm planning to do one more for you guys before Sunday. So I'd like to first see after doing this what other questions you guys are having problems with, and just shoot me a message on Canvas, or definitely Canvas discussion would help. And then I'm going to put all those together and then maybe find similar ones to those to practice with you and get you ready for this test for coming up. So our test is going to be on Tuesday of coming week. So I'll talk more about it, as I said, on Canvas. But it's going to be pretty much the same style as last test. So I hope you guys are ready. To be honest, I'm thinking about Tuesday, Wednesday. Let me just see once I look at your homework from Sunday night. Let's see where people are and see if I need to move it to Wednesday. I just want to make sure that we go with the class, okay? So I'm still debating between Tuesday and Wednesday, but Tuesday at this point is what I had planned. But we'll see, maybe it will be Tuesday or Wednesday. Okay, I hope this was helpful. Again, let me know if there's more problems you want me to do, and I'll be happy to do those.